Here we are looking at 2.6. Given a positive real number, not an integer, print its first digit to the right of the decimal point. So essentially I need to somehow find this. Now we know that we manipulate by the powers of base 10 to move the decimal point. So essentially what we want to do is, well, let's take a look at this. 179, 1.79, 1.79, right? If I have, let's just call num equals 1.79. So if I say num divided by 10, it's going to be 0. That doesn't give me the 7. What if I do divided by 10? Doesn't get me closer to that 7. What if I multiply by 10? And now let's see if I take that number and then modulus 10. Seems like I got 7, but I have a whole bunch of stuff. What if I divide by 1 to get rid of the decimal, whatever's behind the decimal point? So there's a pattern to this. So sorry about that dog. I don't know. I can't keep it quiet. So num equals int. We got to take in an input. To start. Oops. Int input. That's our first step. And then what do we do? Well, how do we get rid of everything behind the decimal point? So let's look at num again. If I divide by interdivision by 1, I get. So now we're working with float division. Now this is something we haven't really explicitly talked about, but if you divide by 1 integer division, it basically gives you 1 and drops the remainder, right? So essentially, if we did num divided by 1, what's the remainder? It essentially almost gets rid of everything except what's behind the decimal point. Okay, so let's take a look at that. That might be interesting. So this one right here, specifically, I get the last number. So if I have, let's say I have 123.456 modulus 1, I get 456, and something weird here. Don't worry about what that means. But if I did that, if I divide by 1, I essentially get everything behind the decimal point as a float, dot 0. Now, if I want to get rid of the dot 0, well, I just have to change it into an integer. Okay, so let's take a look at that. So we say, here we go, we have num. And you know what I'm going to do? I'm just going to use num and restore the same values. So when we talk about this memory space, we're just going to replace this memory space. It's called num. We're just going to store it with whatever's here. We're going to say times 10. Print num. All right, let's run our program. Uh-oh. It's taking a second. So let's say 55. Oh, we need a decimal. So let's enter a decimal, actually. So we say 78,976. I don't think it's running the program. Oh, it wasn't running. Let's run this program again. For some reason, it's taking its sweet time. I wonder, are we connected to the internet? Yes, we are. Let's refresh this page. Sometimes Replit needs to be refreshed. Excuse me for the delay. And yeah, it's funny. None of the work that we did actually ended up working, so let's do that anyway. Let's say num equals int input. So now we take an integer number and we say something like num equals num times 10. And of course, let's print num at the end of it. Print num. And we say 55. Oops. 1.234. Run that again. 1.234. And look, I made a mistake. Why? Because I tried to turn this, which is a string, into an integer. So our first thing, we have to turn this into a float. Okay. And yeah, that's our step that we have to take. So we have to turn this into a float to start. Okay. And let's run our code. 1.234. And we multiply by 10. And we got that 2. So essentially we're after that 2. So before we do anything, let's do num equals num modulus 1. No. Yeah, well, let's see what happens if I do that. 1.234. No, that's not what I want. I wanted to integer division by 1. Let's run that. So if I do that, I say 1.234. I get 12. So I got rid of the 3 and the 4, which is what I wanted. And what else do I want? I probably want to get rid of this 1 as well. So I say num, our same space, we're going to replace it with num. How do we do this? Modulus 10. Run. 1, 2.3456. And we have the 3. Except what we want to do now is we want to change it back. We want to get rid of that 0.0. So we say num equals, it's a float, let's turn it into an integer, num. Run our program, and we have 1, 2, 3, 5, 6, 7, 8, 9, and we get our 5. And that's all we need to run our program. So there's some finessing that's involved in that. First we have to take in a float, we do some stuff with it, and we just have to know that the operations are a little bit different when we work with floats and the other as opposed to integers. That's a few lessons that you have to learn with that's specific to Python. That's it.